right, so we are reflecting over intersecting lines this time. We're going to do it the same way where we reflect over line 1, then over line 2. Okay, when we reflect over intersecting lines, remember it's not the distance that changes, it's the degree of rotation. So the first thing we're going to do is we're going to take our ruler and connect A and the point of intersection of the two lines. We're going to make the angle between A and line 1 X degrees. Okay? And then you can take your mirror, take your patty paper, just do it, I don't care. Where you're marking line 1, you've got A. You've got the angle between them is X degrees, and we are reflecting over the line. So sometimes if you trace over it, it makes kind of a mark, which then is easier to just trace. Okay? Now we need to reflect that over line 2. Make sure you put image A. Don't leave it just A like I did. Now, do you guys see that the angle between line 1 and A image is bigger than the angle between A image and line 2? So we're going to make this angle right here Y degrees. Okay, see right here? X. So, see how A is on this side of line 1? When we reflect it over, it's there. Same on the other side. Now, the angle between image A and line 2 is Y. And then we simply take, there's A image, Y. Make sure you do line 2. And we reflect it over. Okay, I trace it, Y degrees. So I'm not looking for it to be beautifully and perfectly accurate, and if I took a, protractor out, I would measure it and it would be the exact same degree. The issue that I want to see is that whatever is on this side, you've reflected to the other sides. Okay, so the angle between line 1 and line 2 is how much? Line 1 and line 2. X plus Y degrees. And the angle between A to A double prime is how much? How many X's? How many Y's? 2. Okay, so the angle between, and we did this on that first packet. You might not remember it. I didn't emphasize it. But the angle that we make between it, if we double that, that's the angle we go. We talked a little bit about if you want to go 90 degrees, that your two angles of intersection have to be at 45 degrees. We talked a little bit about that. But it's pretty much the same thing we did in the other one, except we're dealing with angles instead of distances. Okay, so you guys are going to do the rest on your own. Shouldn't be too bad. You could do, like literally one today and one Monday, and you'd be done. We're going to look at your homework, though. We're looking at dividing exponents. So the rule is if we have an exponent on top minus the exponent on the bottom. So if it's XA over XB, you go XA minus B. We've got an example right here, but I'm going to do one more with you. Let's do a harder one. Which one do you guys want to do? 8? We can do 8. Okay. So we have 3xy, so we're just going to separate this. We go 3xy over negative 6xy squared. And we've got 4x squared y over negative 6xy squared. I'm going to zoom in. Hopefully this won't. Okay. What's 3 divided by 6? Say it again. 1/2 or, yeah, There's just a -2 on the bottom, right? 1 on the top, 1/2. Okay, do you guys see that this is an x and this is an x? They both don't have an exponent here, so what does that exponent have to be? 1. What's 1 minus 1? 1 minus 1 is 2.
Let's say plus 2.
1 minus 1 is 0. So the x's are gone. Y minus y2 is y1, so a y goes on the bottom. 4 over 6 ends up giving me 2 over -3. x2 minus x1 is x. Y minus y2 is just y. Now we can put these together. We get 2x. What's 2 times 3? 6. And a negative times a negative is a positive. And y times y is y squared. Now 2 over 6 can reduce to 3. I'm not sure why we're talking while I'm going over this, but hopefully you got it. So that's your homework, is those 20 problems. I highly, when we get to 8 was a little bit harder. 10 might be a little bit harder, but a lot of them, like 1 through 7 is super straightforward. 11 through 16 is really straightforward. Okay, so it looks like a lot, but it really isn't. You're just subtracting the exponents. Okay, make sure you try your classwork though too. Don't do like last time.